for number 3, which equation has the same solutions as the equation given? So here's that word solutions. So remember, for solutions, we are trying to figure out a value for x that makes this true. Now it's a trinomial, so that means we're going to have to do a couple steps here. So remember, solutions can be interchanged with roots, x-intercepts. Sometimes it'll say to solve the equation. So all those lead to the same process. If I take a look here, we have an equation and it's already set equal to 0 for us. Whenever we're trying to find the solutions, you need to set the equation equal to 0 first. Now, if I take a look at my answer choices, I notice my answer choices are products of binomials. So I'm seeing two sets of parentheses being multiplied. When I see that, that's an indication to me that we're going to have to factor. Now remember, there are different methods of factoring. The first thing we always check for is a GCF. But there's no GCF here. I don't see a number that goes into all of these. So the second thing we do is use our magic X and our grouping method together. Now, if that didn't work, we'd move into difference of perfect squares, but that's not for this problem. We're going to stop here at the magic X and grouping. We're going to use that. So whenever we're using our magic X, so we're going to draw our magic X. Remember, the magic X won't always be drawn or won't ever be drawn for you. You'll have to draw it yourself. The number on top is the product, and the number on the bottom is the sum. The product comes from multiplying the first and the last term from our equation. Don't forget the signs in front. So the first term is 3, the second term is -2, so we multiply them 3 times -2, and we get -6. And our sum comes from the middle term. Our middle term here is what's in front of the x. Although it doesn't seem like there's a number in front of the x, there is an invisible 1. So our sum is a positive 1. So we're looking for two numbers that will multiply to -6 and add to 1. So I'm just going to focus on numbers that multiply to 6 right now. We'll focus on the negative in a minute. So we have 1 times 6 gives us 6, and 2 times 3. And we want to choose the pair that'll give us a sum of 1. That means they're going to be 1 away from each other, which is this pair 2 and 3. So our factors are going to be 2 and 3. I'm going to write the 3 first and then the 2. But if they're both positive, a positive 3 times a positive 2 doesn't give us a sum of -6 and doesn't give us, or a product of -6 and a sum of 1. So we have to figure out which one of these has to be negative to get a sum of positive 1. So if the 3 was negative, well, a -3 plus 2 gives you -1. But we want a positive 1 sum, so the 2 will be negative. 3 and -2 are our two factors. Why did we find those? Well, we found our two factors so we can split up this middle term into our positive 3x and our -2x. So now we'll bring down the first term and the last term, the 3x squared and the -2. Now that we have our 4 terms, we're just going to look at the first 2 terms. And we're going to look for a GCF. So a GCF, what goes into 3x squared and into 3x? Think numbers and variables. Well, 3 goes into both of them, and they both have an x. So 3x is your GCF, which means I'm going to divide both my terms by 3x to get what's left inside the parentheses. So 3x squared divided by 3x, your 3's cancel out. X squared divided by x is x. And then 3x divided by itself, 3x, just gives us 1. Now let's take a look at our last two factors, -2x and -2. Well, the only thing that goes into both of those is going to be 2. But when this term here is negative, you're going to pull out a GCF of -2. So we have negative 2. And let's divide to see what's left over for our parentheses. It should match up to this first set of parentheses, x plus 1. So a negative 2x divided by a negative 2, your negative 2's cancel, you get x. And a negative 2 divided by a negative 2 is a positive 1. So far I know we're on the right track because our two parentheses match up, x plus 1. So in our answer, final answer, x plus 1. And in the second set of parentheses, we take our two GCFs on the outside and put that inside parentheses, 3x minus 2. Now we have our answer in factored form. If I take a look back at the answers or the solutions, I'm looking for one that matches mine. Now, I don't see one that matches identical to this, but multiplication is commutative, which means I can change the order. I can put the 3x minus 2 in front and the x plus 1 second. So now that should match up with an answer. So it matches up with answer choice 1. Let's check out number 2, where we're graphing an inequality. So when we have inequalities, we know two things. One, there's going to be some shading. And two, we have to decide if we're going to be using a solid or a dashed line. So when we're writing an equation of a line, we use the format y equals mx plus b. That is slope-intercept form. M is your slope, and b, that's b, b is your y-intercept. So your y-intercept is where the line hits the y-axis. That's always the easiest place to start. So where this line hits the y-axis is, if I zoom in, right here at 4. That means my b value is going to be 4. So if I put that into my equation, y equals mx plus, I'm going to replace b with 4. So if I take a look at my answer choices here, I can already cross out the last two because in number 3 and number 4, they're saying the y-intercept is negative 3. But it's not. We don't cross down here. The y-intercept is 4. So if you take a look at 1 and 2, the only thing that's different is the inequality sign. So they both have a slope of negative 3, and that slope of negative 3 means negative 3 over 1. So that means go down 1, 2, 3 to the right 1, and you'll hit the line again. Go down 1, 2, 3, go over once and hit the line again. So that's what your slope means, and they both have the same slope, but what's different here is your inequality symbol. The first one is a greater than or equal to symbol, and the second one is a less than or equal to symbol. Well, if I take a look at the shading here, I'm shading to the right of the line, which is everything greater than the line. So I want to choose the inequality that matches up with that, which is number 1. Just as a reminder, if you have a less than or equal to or greater than or equal to sign, you're going to be using a solid line. But if you have a less than or greater than sign, it doesn't have the or equal to. That's when you'll be using a dashed or a dotted line.